All right, so today we're going to be talking about intercept form. So if you're looking at this sheet again, it's the one right in the middle there. That's where we're going to start to focus today. So intercept form, also known as factored form, depending on who you talk to, factored form, is a little bit different than what we're used to. So it has new letters that are specific to intercept form. So x minus p, x minus q. So a is familiar, and it still does the exact same thing it always does, so it's our vertical stretch and shrink. However, these two new letters, p and q, are just your x-intercepts. So when I'm looking at the graph, I can always assume that if I can tell what the x-intercept is, that is going to be at p, 0, and the other one will be at q. It does not matter what order they go in. I could have put q over there and p over here, doesn't matter. Y-intercept is not going to be anything special. We still have to find it just like we normally would, where we plug in 0 for x and find out a number for y. The difference between intercept form and vertex form is that the vertex is no longer necessarily easy to find. So looking at the graph, the reason we talk so much about the symmetry of a intercept form graph is because it helps us to figure out how to compare things to each other. So the distance from this x-intercept to the axis of symmetry and from this x-intercept to the axis of symmetry, those things are the same. So if this is 2.1 units away, so is this, no matter what, because the graph is perfectly symmetrical along this line. So that's going to become super important because that means that those two spots, those two x-intercepts, are equal distance away from our vertex, meaning that the exact middle of those 2 points, or the average of those 2 points, will be our vertex. Now, if you remember how to calculate an average, it's where you take everything up, add them all up, and divide by however many numbers you're adding. That's exactly what you're going to do here. You're going to take your two x-intercepts, you're going to add them together, and you're going to divide by the number of things you're taking and adding, which in this case is 2. That will give you a number, which you then can plug in to get your y value. Our domain, same as always, no matter what, every single parabola has a domain of all real numbers, or negative infinity to positive infinity. The range will, just like before, go from the y value of your vertex to positive or negative infinity based on your a value. The axis of symmetry, just like before, will use that same x value from your vertex, so that p plus q over 2. Let's get into this. So whenever you're given an equation to graph, the first thing you're going to want to do, just like when you're dealing with a vertex form equation, is find the vertex, put it in the middle of your table. So p in this case is 1, q is 3, so I'm going to add them together, 1 and 3, divided by 2, so 4 divided by 2 gives me 2. X value of my vertex is at 2. Then I need to pick new x values to go around it, so equal distance away, 1 and 3, 0 and 4. Now I'm going to start to plug things in. So the reason that we picked things the way we did is so that the outsides matched. So 0 and 4, 1 and 3 will always match. So I'm going to plug in 0. So 0 minus 1, 0 minus 3, I get negative 1 times negative 3, which gives me 3. Now if I plug in 4, I should get the same thing. So 4 minus 1 would be 3. 4 minus 3 would be 1. I would get 1 times 3, which is 3. Plugging in 1, 1 minus 1, 1 minus 3, I get 0 times negative 2, which is 0. And then I didn't get the y value of my vertex originally, so I do have to plug that in to find it. So 2 minus 1, 2 minus 3, I get 1 times negative 1, which is just negative 1. So this graph doesn't quite fit on here because it's not negative. That's all right. We'll plot what we can. So 2, negative 1, 1, 3, and then 0, 3, and 4, 3 go off my graph, which is fine. No big deal. Should look like that. Okay, so my vertex, like we said, was at 2, negative 1. Axis of symmetry will always be at the same thing as your vertex, so 2. Y-intercept is wherever x is 0, so in this case it is at 0, 3. X-intercepts, conveniently we found those in our table. It was at 1, 0, and 3, 0, because that's wherever the x or the y value is 0. Concavity, this graph is concave up, it curves upwards. Domain, all real numbers no matter what. So on a test, if you were to ever leave that blank, I'm going to be fairly upset with you because every single time, no matter what the graph looks like, it's always all real numbers. Finally, the range goes from -1 to positive infinity. We know that because the a value is positive. Let's give it another shot. So p is -3, q is 1, so I add them together, -3 plus 1 divided by 2, get -2 over 2, which is -1. So in my table, middle value is -1, then I have to find my outside values. So I'm going to pause for a minute, let you see if you can find them. You should be getting 0, 1, -2, and -3. Now, I need to plug those in again. -3 and 1 should have the same y value. -2 and 0 should have the same y value. So I'm just going to be plugging in the 0 and the 1 because if I can help it, I choose not to deal with negative numbers. So 1/2, 0 plus 3 would be 3. 0 minus 1 would be -1. So I get 3 times -1, which is -3, times 1/2 is -1.5. So that was me plugging in 0. Now I'm going to plug in 1. So I get 1 plus 3, which is 4, 1 minus 1, which is 0, times 1/2. So 1/2 times 4 times 0, no matter what, is 0, because anything times 0 is always 0. And I got to plug in -1. So 1/2, -1 plus 3, -1 minus 1. So I have 1/2 times 2 times -2. So that'll give me -4 times 1/2 is -2. So again, this one goes off the graph, that's fine. So -1, -2 would be like down here-ish. 0 would be at 1.5 and 1.5, 1, 0, and -3, 0. So I end up with about that. Okay. Vertex, right from the middle of our table, is -1, -2. Axis of symmetry, again, this should always match between these two. Y-intercept, wherever the x value is 0. So if it's not on my table, which it is in this case, I would plug it in. Then I'm looking for wherever the y values are 0. Conveniently, I found both. So -3, 0, 1, 0. Concavity, this graph is concave up because it curves upwards like a U for up. Domain, all real numbers. Again, if you ever leave that one blank, I'm going to be fairly upset because that is always, 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 no matter what, all real numbers. Range, since our graph is concave up, it goes from -2 to positive infinity. One more because I have a challenging one here. So this one's tough because there isn't like a number being subtracted or added to x. So your p-value in this case is actually just 0. Q would be 6. So finding my middle, 0 plus 6 divided by 2 would be 6 divided by 2, which is 3. So in my table, the middle would be at 3. So 2, 1, 4, 5. See if you can find those y values. I'll give you a second to pause the video. So pause the video and then see if you can find the y values. All right, so you should find your y values by plugging in each number. So if I plug in 3, I get 3 times, or 2/3 times 3 times -3. So -9 times 2/3 would be -6. If I plug in 4, I get 2/3 times 4 times -2. So -8 times 2/3 would be -16 over 3. I'm going to leave it as a fraction because I'm doing that in my head. Do the same thing with 5. So 2/3, 5, -1, so I get -5 times 2/3, which would be negative 10 over 3. Now, if you'd like, you can type those into a calculator and get out exact answers there. 16 over 3 is just a little bit bigger than 5, so that would be about there, about there. 10 over 3 would be about a little bit bigger than 3, so there and there. Okay. So, vertex 3, negative 6. Axis of symmetry, again, always matches. Y-intercept. This time I didn't find it on my table, so I've got to plug in 0. So if I plug in 0, I have 2/3 times 0 times negative 6, so no matter what, it works out to 0. Conveniently, that's one of our x-intercepts. Now the other one we would have to find, which is not on our table, but like we said, this is always our x-intercept, so the other one is at 6, 0. Concavity is up. Domain, same as always, all real numbers. And your range will go from negative 6 to positive infinity. All right. So I want you to try and graph these two equations. I didn't leave you any graph paper this time. When you're done, come up and check them with me, and I will tell you whether or not you've got this figured out.